Okay, hello there again. We're going to finish up chapter 6 homework. And so we left off with number 63. And first problem here is the perchlorate ion. Chlorate is a ClO3. It's in the 3 oxygen block, and the charge would be a 1 minus. And so per 8 is one more oxygen, so it's going to be ClO4 minus. And then we have barium carbonate. Barium is in the group 2, so it's fixed charge 2 plus. Carbonate is in the 3 oxygen block, so it's going to be a CO3. And then counting down from boron, borate's a 3 minus, therefore carbonate's a 2 minus. So it's going to be a barium with a 2 plus and a carbonate with a 2 minus, so just be a CO3. And then over here we have NH4, which is ammonium with a positive 1 charge, and then iodide. So this would be ammonium iodide. And then finally, this would be a molecular compound. Over here, this is an ionic compound because we recognize the ammonium there. But over here, this is going to be phosphorus trichloride. So we can check the answers here. ClO4 minus, BaCO3, ammonium iodide, and phosphorus trichloride. All right, 64. Calcium fluoride. Calcium fluoride. Calcium is group 2, fixed charge 2 plus. Fluoride is an F minus, so we need 2 fluorides for every calcium. So CaF2 should do it. And then sodium bromide. Sodium is a +1, bromide's a -1, so NaBr should take care of that. Aluminum iodide. Aluminum is fixed charge 3 plus. Iodide's fixed charge 1 minus, so we'll need 3 iodides. We'll get Al(I3). And finally, the last species there is HS minus. HS minus is the hydrogen sulfide ion, or bisulfide. I guess it's bisulfide. I'm not sure. Hydrogen sulfide, though, we could say for sure, and that would be different than H2S. H2S and HS minus. You know, H2S and HS minus, both of those could be called hydrogen sulfide. Therefore, to differentiate the two, we'll call HS minus hydrogen sulfide ion. Okay, then 65. MgBr2 is just magnesium, which is fixed charge bromide. Magnesium bromide. Aluminum nitrate. Aluminum is 3 plus. Nitrate is in the 3 oxygen block. So we count down from borate. Borate's a 3 minus. Carbonate's a 3 2 minus. Nitrate is a 3 1 minus. So it's NO3 minus. We got that. And so we'll need 3 nitrates for every aluminum. And so Al parentheses NO3 3. And then oxygen difluoride is a binary molecular compound. That would be OF2. And then Na3PO4. The sodium ions with phosphate ions, so it's called sodium phosphate. For 65, sodium phosphate. So the ionic compound, we don't have to use the ditris, that kind of stuff with that. Okay, let's go to 66. That's calcium there, Ca, and CO3. CO3 is carbonate, so calcium carbonate. Calcium is 2 plus, carbonate is 2 minus. Then we have the mercury 1 ion. The mercury 1 ion that's the oxidation state. That's not the total charge on the ion. And so mercury 1 would be an Hg2 2 plus. Like this. And this is one you just have to memorize. Mercury 1 is tricky. It's polyatomic. In fact, it's diatomic. Each mercury has a +1 charge, and 2 of them add up to 2 plus. And then cobalt 2 chloride. Cobalt 2, it's a variable charge. 2 3. The common charge is there, and so this would be cobalt 2. Chloride's fixed charge at -1, so we'll need 2 chlorides for every cobalt. So it would be CoCl2. Or cobaltous chloride. Cobaltic would be cobalt 3. And then the last one here is silicon with oxygen. And so this one has the common name quartz, or this is it's borderline. Silicon's borderline. Silicon is what we call semimetal. So there are 2 ways you can name this. You can name this as a binary molecular compound, and consider silicon as more of a nonmetal. Then it would be called silicon dioxide. Or you could name this as a ionic compound, treating silicon as a metal. And in that case, it would be called silicon Roman numeral 4 oxide. Because each oxide would be a -2, and therefore silicon would have to be plus 4. So silicon, Roman numeral 4, oxide. And that would, I'll just write it out here, silicon, Roman numeral 4, oxide. Like that. Okay. Going on here, we have LiNO2. So we got to think about NO2 first. Li is lithium, and lithium is an alkali metal, so it's Li plus. And then NO2 must be a minus. But we look at a nitrate. What is nitrate? A nitrate would be in the 3 oxygen block. So we go borate, carbonate, nitrate. All 3 oxygens. And therefore this is 2 oxygens, so this must be nitrite. Okay, so this is lithium nitrite. And then SO3, a lot of people confuse SO3 with sulfite, because sulfate's SO4, but it's SO4 2 minus. Sulfite would be SO3 2 minus, and this has no charge, so this would be a binary molecular compound, which we would call sulfur trioxide. Sulfur trioxide. And then we go on to this one. It's sodium ions and oxide ions, ionic compound. This would be sodium oxide. And then ammonium sulfate. Ammonium is a +1. Sulfate is SO4. It's in the 4 oxygen block. And so we start off with silicate. It is a 4,4. Phosphate is a 4,3 minus. And therefore sulfate is a 4,2 minus. SO4 2 minus. What we get. And so ammonium sulfate would be just NH4 taken twice, SO4, ammonium sulfate. So it would be something like that there. Actually, I didn't have to draw that because the answers are here, right there. So you can see that. Alright, moving on to number 68, dinitrogen tetroxide. Well, that's binary molecular. 2 nitrogens, 4 oxides, so N2O4. N2O4 would be it. And then we go to a monatomic anion. Monatomic anions end in IDE, like for example chloride, bromide, iodide, oxide. This would be nitride, N3 minus. We can tell it's going to have a 3 minus charge from its position in the periodic table. And then we have calcium. And we got to look for what chlorate is. When we have an oxyanion, an anion that contains oxygen like this, it's going to have a T in there, so it's either going to be an 8 or an 8. And in this case, we look for chlorate. Chlorate is in the 3 oxygen block, so we start the 3 oxygens at BO3, BO3 3 minus, and then go to carbonate, which is a CO3 2 minus.